We're going to see the application of AI to safety barrier management, which is demoed by Ian, who could not be here, but I'm going to provide some initial context about this. So for those that don't know, safety barriers, they are used in high-risk facilities, and they're designed to prevent major accidents, hazards from happening, particularly in offshore oil and gas facilities, right? So these barriers are, organized in a way that they have safety barrier functions, which in turn are connected to safety critical elements. And barrier functions can be part of a system, they can be part of a performance standard. And this is all modeled in a knowledge graph that actually drives the whole performance of the safety barrier system. Of course, safety critical elements or barrier functions can be impaired, reducing the effectiveness of the barrier. That's the whole objective of the software, is to monitor the health of those barriers based on impairments. What are the sources of impairments? Well, corrective preventive maintenance, risk assessments, inhibits in the field, device alerts, etc. Anything that impairs the normal function of those safety barriers. And our BSP barrier status panel is designed to monitor the health of all those barriers and allow managers to prioritize maintenance work. So the sources of impairments, as I said, can be many things: risk assessments, planned maintenance, corrective maintenance, safety of observations, device alerts, inhibits, even competency of staff. In the example that Ian's going to talk about, he's going to talk about planned maintenance and corrective measures, corrective maintenance, as well as risk assessments done in a system called Synergy. And you will hear him mention Synergy and both planned and corrective maintenance activities that impair certain barriers. Okay, with those impairments, what the system does is it calculates the status of all the barriers, okay, and then presents that information in an interactive form. So in a visual form, in a display, typically a laptop or a screen, a communal display. And what we wanted to explore is different ways to convey that information with AI. So when we talk about AI, we see 4 levels, from assistive, authoritative, enhanced, and executive level, okay? We are working at the agentic and authoritative level at the moment. This is where we are. At the moment, we do have a ChatGPT agent for Eigeningenuity who knows about all the functions in Eigeningenuity. And you could ask it questions. You could actually look for this GPT in ChatGPT, and it will answer questions about ingenuity. But this research, this project we're doing with a barrier system is using graph RAG as a technique, which is RAG means retrieval augmented generation, where basically we're going to access information in the knowledge graph and in a status database to be able to augment the responses from the agent, okay, from the agentic agent. Our focus on this is to come up with a solution that is trusted, explainable, and does not hallucinate. And that's the objective, okay? Now, in general, we are actually very open to other people, other third parties, building AI solutions on top of the data that we share or we have in our applications. Okay, so with that, I'm going to play the video now with Ian doing the demo of the system.
So this is the architecture behind the chatbot. It's quite simple. A user asks a question into a Streamlit chatbot app, which connects with Microsoft Semantic Kernel. This interprets language query and then queries both the Neo4j structure for the barrier panel and also the Postgres status database. It takes the response from those 2 databases, combines them, and then returns an answer back to Streamlit to present to the user. It's fairly straightforward, so let's have a look at this in action. So I could ask a question, something like, what areas are most at risk? That's a fairly vague question, but the chatbot will go and query the structure to find out information about the areas and check the status to return the ones which are most at risk. And it's ordered them here by status and score. So it's put the yellow one first, because that in some ways is perhaps the one at higher risk, even though it's got a slightly lower score. And it's then listed the next 4 areas, which are all green, but they have some kind of impairments. Let's see what the impairments are. So now it's going to get a bit more information about the derivation of the scores. Okay, so we can see it's presented the results here. So for area 16, and it's categorized them for us, which is nice. So we've got some preventive work orders and a synergy case. For area 15, again, we've got a work order, 4 corrective work orders, but no synergy cases, and so on. So it's pulled out all that information and it's presented it nicely. And we could ask it what work orders affect the most performance standards. Here we go, rather than areas. And I'm going to ask it to put the results in a table.
Can you ask for information on a specific work order or synergy case?
I can. So let's have a look. Okay, it mentions this one. So, okay, so for this particular work order, it's affecting 67 things, which it's listed some of them here because there's quite a lot, but it's grouped them quite nicely into functions, areas, systems, major accident hazards, and performance standards. So even though I didn't ask it specifically to do that, it's been quite sensible, and it's understood that that's the kind of thing I might be interested in, and it's presented it in that way. Let's have a look. Let's see if we can, hopefully that will come back as a table. Yes, so it's pulled out the areas. Now it's only listed these, however many there are, because these are the only ones that have actually got a status in the database at the moment. So there are other barrier areas, but there's nothing in the status database. So it doesn't have any status information to display, so it hasn't included those, which again kind of makes sense. And as we can see, it's sensibly ordered them by status. So it's put the yellow one at the top and then the green ones, and then finally the two that don't actually have any status score. That's because these preventative work orders don't actually generate a status yet, because they're probably ones that are coming up but haven't been, aren't due yet. So they're there, but they're very low risk. And it's presented the result there in quite a neat table.
And since it knows how everything is connected, you can ask what is, for example, area 13 affected by, and then it can list to.
Yeah, so area 13 is directly affected by these things, but we could say, I'll just put it in a table because it'll be easy to read. Okay, so it's saying that area 13 is linked to this major accident hazard and these 2 barrier functions, which from memory is correct. And then it's saying here are the work orders that impact area 13. I mean, I could now say, so I'm not going to see if it's going to be able to tell me what impacts these 2 functions. I haven't put them specifically by name. It should understand the context that I'm talking about those 2 and just return the results for those. Here we go. So it's understood I'm asking about those 2 functions. And it's told me what their sub-functions are, which is great, which I didn't actually ask it for, and it hasn't given us what directly impacts them. It may be that there is nothing that directly impacts those barrier functions. The work orders may relate to other things that affect barrier area 13. But that's great. It's given that information. It's quite easy. You can ask it quite complex questions, and it understands and gives pretty good answers.
Yeah, it looks very nice. And how was it to create it, to build it, to train it?
Not that difficult once I'd understood how it thinks. It's a partnership, if you like. So to train it, I need to give it guidance in a structure and in a style that best suits the way that the semantic kernel expects them. So that took a little bit of time, but once I got the hang of that, it's actually quite simple to modify it to work with other structures and other databases.
Yeah, perfect. Did you identify any particular challenge in that part of identifying how it thinks?
Yeah, I think the toughest thing is that AI is not very good with numbers, strangely. One of the biggest challenges I faced early on was getting it to sort the data in numerical order. It's great at sorting things alphabetically, but when it comes to numbers, it's not so good, which is bizarre, really. But I've managed to overcome those with various techniques.
That's a good overview. So we might ask ourselves, okay, what is the use case for these techniques? Well, we thought about these use cases. For example, if we want to just produce a report of barrier status on the fly, by specifying verbally, in text, what exactly we need, and the system can produce the report. Also, say we're in the field and we don't have access to a computer or a laptop or anything, we could think about voice-activated inquiries. So somebody in the field needing very specific information about barriers or anything similar to this, because the knowledge graph feeds a lot of different types of systems. It could respond to that, or any maybe custom management summaries as well.